When scientists turned on Webb, they weren't expecting a revolution, just a clearer view, a deeper look, a chance to confirm what we already believed. Instead, Webb started returning images that didn't quite make sense. Galaxies forming barely 100 million years after the Big Bang. That's like walking into a bakery and finding a fully decorated cake while the oven is still preheating. Structures forming too fast, and objects that don't behave like anything we recognize. Not stars, not galaxies, not even the already strange little red dots scientists were struggling to explain. Just something different. At first, it looked like progress, but the more data came in, the more it started to feel like something was off. Because instead of answering questions, Webb is raising deeper and far more unsettling ones. So what Webb actually saw, how scientists verified these observations, and why this might be a bigger problem than it first appears. Because this isn't just about strange galaxies or unusual objects. It's about whether our understanding of how the universe began and how it evolved might be missing something fundamental. The first major issue Webb revealed is a problem with timing, and it's bigger than it sounds. According to the standard cosmological model, the early universe should have taken its time. After the Big Bang, matter gradually cooled, collapsed under gravity, and began forming stars. Over hundreds of millions of years, those stars gathered into small galaxies, which later merged into larger ones. It's a slow, step-by-step process, but Webb is seeing something that doesn't match that sequence. By detecting extremely distant objects using infrared light, scientists can observe galaxies as they existed billions of years ago. This works because of redshift. As the universe expands, light stretches, allowing us to look further back in time. And when Webb looked back to just 100 to 300 million years after the Big Bang, researchers expected to find simple, faint structures. Instead, they found galaxies that already looked developed, not just forming, but structured, bright, and massive. These observations weren't taken lightly. Scientists used spectroscopy to analyze the light from these galaxies, measuring their composition, distance, and age. Multiple teams repeated the measurements, and the results kept pointing in the same direction. Some of these galaxies appear to contain billions of stars, far more than expected for such an early stage of the universe. This creates a serious tension, because under current models, there simply hasn't been enough time for galaxies to grow this large. Even with optimistic assumptions about star formation, the numbers don't fully add up. So what are the possible explanations? One idea is that star formation in the early universe was far more efficient than we thought, meaning gas collapsed faster and built stars at extreme rates. Another possibility is that unknown physical processes helped accelerate structure formation. But here's the issue. None of these explanations completely solve the problem. The gap is still there, and when a timeline stops making sense, it's not just one detail that's affected, it's everything built on top of it. Which brings us to the next issue Webb uncovered. Because it's not just about what appeared too early, it's also about what didn't appear at all. If galaxies were forming that early, there's something we should definitely be seeing more of: smaller galaxies. According to our current understanding, large galaxies don't just appear fully formed. They're built over time from smaller structures, tiny proto-galaxies that merge and grow into larger systems. It's often described as a bottom-up process. So logically, the deeper we look into the universe, the more of these small galaxies we should find. But Webb is showing something unexpected. Instead of a sky filled with faint, low-mass galaxies, astronomers are finding fewer than predicted. Not completely absent, but not nearly enough to explain the number of larger systems we're observing. These conclusions come from deep field surveys, where Webb observes a tiny patch of sky for long periods, capturing extremely faint objects. These surveys allow scientists to build a statistical picture of galaxy populations across different periods of cosmic history. And the pattern that's emerging is difficult to ignore. There are too many developed galaxies, and not enough smaller ones to explain them. This creates a gap in the formation process itself. Some researchers suggest that small galaxies may have merged very quickly, making them hard to detect individually. Others propose that they could be hidden by dust or simply too faint to observe clearly. But even when accounting for those possibilities, the discrepancy remains. And then Webb found something even more unusual: objects that don't clearly fit into any known category. Some of these are being referred to as little red dots, compact sources with unusual brightness and spectral signatures. They don't behave exactly like galaxies, stars, or typical black holes. When scientists analyzed their light, they found signs of extreme density, possibly linked to rapidly growing black holes or intense star-forming regions. But the exact nature of these objects is still unclear, and that uncertainty matters, because when observations don't fit into existing models, it usually means one of two things. Either we're misunderstanding what we're seeing, or there's something missing from the theory itself. At this point, it's not just a single anomaly, it's a pattern, and that pattern is starting to point toward a deeper issue with how we think the universe evolved. As these findings continue to build, the implications are starting to reach beyond galaxies and into the foundations of cosmology. One of the key assumptions in our understanding of the universe is something called the cosmological principle, the idea that on large scales, the universe is uniform, that it behaves roughly the same in every direction. This assumption is essential because it allows scientists to create models that describe how the universe expands and evolves over time. But some recent observations are beginning to challenge that simplicity. There are hints, still being studied, that different regions of the universe may not be evolving in exactly the same way. If that turns out to be true, it would suggest that the large-scale structure of the universe is more complex than we thought. And that's not a small adjustment, it's a shift in the foundation. Then there's dark energy, the force believed to be driving the accelerated expansion of the universe. For a long time, it's been treated as constant, but some interpretations of recent data suggest it might not be perfectly stable. It could be changing over time. If that's the case, then the equations used to describe the expansion of the universe may need to be revised. And that affects everything, from predicting the future of the universe to understanding its past. Webb has also contributed to another puzzle, the existence of extremely massive black holes at very early times. Under current theories, black holes grow gradually by pulling in matter, but some of the ones Webb has observed appear too massive for their age, which raises an uncomfortable question. Did they form in a completely different way? Some theories suggest direct collapse black holes, formed from massive gas clouds without first becoming stars. Others explore more speculative ideas, including models proposed by physicists like Roger Penrose, where the universe may go through cycles rather than having a single beginning. These ideas are still being debated, but the reason they're being taken seriously is important, because when multiple independent observations all start to challenge the same model, it's usually a sign that we've reached the limits of our current understanding. What Webb is showing us isn't just new discoveries, it's a shift in perspective. The universe isn't behaving exactly the way we expected. Timelines don't fully align, structures appear without clear origins, and some objects don't fit anywhere at all. This doesn't mean everything we know is wrong, but it does mean something is missing. And that's where science becomes interesting, because every gap in understanding is an opportunity to go deeper. So the question now isn't just what Webb has found, it's what those discoveries are trying to tell us, and whether we're ready to rethink the story we've been telling about the universe. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.